All right, so today in this lecture, I'm going to basically solve the classwork problem from chapter 11, simple harmonic motion and waves. Okay, all right. So the first question is, what is the force constant for the suspension system of a car that settles 1.20 centimeter when an 80 kilogram person gets in? Okay, so if you remember, the force constant is basically the spring constant or spring stiffness constant. Okay, so remember that when the external force, okay, so let me just write down the Hooke's law and then the external force. Okay, so Hooke's law tells us that the restoring force is equal to these Kx, and then external force is equal to Kx. Okay, here basically this person is exerting gravitational force on the suspension system. Okay, so that means we have to use this equation, okay, to determine the force constant K. So if I solve it, I get something like this. Okay, and F external is basically the weight of this person, mg, and x is basically this. So m is 80 kilogram, okay, g is 9.80, and x is 1.20, but we have to convert it into meter. So centimeter to meter is 10 to the power minus 2 meter. Okay, now if you solve this equation, if you put these values, all these values in your calculator, you should get it something like this: 6.53 times 10 to the power 4 Newton per meter. So the spring constant or the force constant is 6.53 times 10 to the power 4 Newton per meter for the suspension system of this problem. All right, let's move on. The next question is, okay, spring stretches when 150 meter when a 0.3 kilogram mass is gently suspended from it. It's basically very similar to the last problem. Okay, the spring is then set up horizontally with same mass resting on the frictionless table. The mass is pulled so that the spring stress to 0.1 meter from the equilibrium point and released from the rest. Okay, so first we have to find the stiffness constant, spring stiffness constant, and then amplitude, and then the maximum velocity, and then the magnitude of the velocity when the mass is 0.050 from the equilibrium, and the magnitude of the maximum acceleration, total energy, and the kinetic and potential energies at half amplitude. So a lot of things we have to calculate here. Okay, so the first one, A, is the spring stiffness constant. So we basically use the same equation that we use in the question number 1. So K equal to F over X. F is basically mg here, and X, m is 0.3 kilogram, okay, g is 9.8, and X is 0.150, so 0.150 meter. Okay, so here we don't need to convert because here it's still in meter. Okay, so if you plug all these values in your calculator, it should give you 19.6 Newton per meter. Okay, so that's the first one. It was easy. B is also easy. Okay, so it says that so you first determine the spring constant, and then the mass is now in the horizontal, that this spring mass system is on the horizontal table. Okay, and you stretch the the spring 0.10 meter from the equilibrium point. Okay, so what it tells us, it already give you the information to determine the amplitude, right? Amplitude is basically when you pull it to some distance, okay, and then release it, it will be oscillating between that distance and the negative of that distance, okay, and that distance is basically the amplitude. So here, without thinking too much, we can say that the amplitude is equal to 0.100 meter, okay. And the number C is Vmax, right? If you remember, we already derived an equation that was Vmax equal to omega A, right? And omega at some point we determine is equal to K by M A, right? So what is K? K is 19.6, M is 0.3, and then A is 0.100. So the V max then will be equal to, if you plug all these values in your calculator, it should give you this value. Okay, so we got the spring stiffness constant, we got the amplitude, we got the V max. Okay, the next one, number D, is the velocity. Okay, number D is the velocity V. Okay, if you remember, we derived another equation, something like this: V max square root of 1 minus x square over a square. Okay, so very similar. I mean, here I did some modification, okay, and because because this equation is given in the list of equation, that's why I use this equation. But the equation we derived in the lecture is a little bit different, okay, but yeah, it's basically the same equation. Okay, so V max is 0.808, okay, square root 1, and x is basically these, okay, so 0.05 meter square, and amplitude is 0.100 square. Okay, now if you plug these in your calculator, you should get the velocity is equal to 0.700 meter per second. Okay, so the velocity at this distance, at this displacement, at a 0.05 displacement is equal to 0.700 meter per second. Number E is the maximum acceleration. Okay, A max. So there are many ways to solve this. Okay, you can determine, you can use omega square A. Okay, there are other way. Okay, so omega square is K over M, right? The square root of K over M, and then square is basically K over M and then A. So it's basically K over M A. So K is 19.6, M is 0.3, and A is 0.1. So A max will be equal to, if you plug all these values in your calculator, it will be equal to something like this: 6.53 meter per second square. All right. All right. Two more question. right? The total energy and the energy at half amplitude. Okay, F is, so the next one is F is the total energy. So the total energy you can determine either this equation, okay, or there are another equation, half m v square max. Okay, so both equation will work. Okay, you know that between minus a and a, the total mechanical energy is always constant. Okay, always equal to E. But there are three equations we wrote. Okay, one of them is this one and another one is this one. So we can, to determine the um, the total energy, we can either use this or that. Okay, so this tells us, so I'm going to use this equation basically. Okay, so half K is 19.6 and A is 0.1 square. Okay, and that gives me 0.098 joules. Okay, so that is the total energy. And then and then the last one is the kinetic energy and the potential energy at uh, at half amplitudes. Okay, so half amplitude means A over 2. Okay, A over 2 means 0.1 over 2 is equal to 0.05 meter. Okay, so we can easily determine the potential energy because potential energy is equal to half K x square, right? So half K is 19.6 and x is 0.05 square, and that is equal to 0.0245 joules. Okay, so this is the potential energy. Now the kinetic energy, there are two ways to determine the kinetic energy. One way is determining the v square, v first, and then plug the value here. Okay, actually we determine the v when x equal to 0.5, right? So it is basically this one. Okay, so we can use this value, this v here, because you already know m. So that's one way. Another way is to use this equation. So E equal to kinetic energy plus potential energy. Okay, so the kinetic energy is equal to E minus potential energy. Okay, so we know the E is this one, potential energy is this one. So we can just subtract them and then get the kinetic energy. Okay, and that will be equal to 0.0735 joules. Okay, so yeah, that's a very big problem. I mean, there are a lot of problems here, right? I mean, problems is, the question here. So yeah. All right, so we did all A to G. Okay, very good. Now let's move on. So here we have a spider web. So here we have to model the spider web as a spring, and then the spider and this bug as mass. Okay, so it's basically very similar to the spring mass system. Okay, so this is the mass of the spring mass system, and then this is the frequency of the spring mass system. The first we have to determine the force constant. Okay, so we are given m equal to 0.30 gram. So it will be you need to convert it into kilogram. Okay, so gram to kilogram is this one, and then the frequency is given to 15 hertz. Okay, All right, we have to calculate k. All right, what is k? So to solve this, okay, we have to use this equation. F equal to 1 over 2 pi k over m. Okay, so let's square both sides. So it will be 1 over 4 pi square k over m. So if I solve it for k, I get 4 pi square f square m. Okay, so 4 pi square and then 15 square and then m. Okay, it will give me 2.7 Newton per meter. Okay, so this is basically the spring stiffness constant of the spider web. All right. All right, so we did the first one. The second one, it tells us that at what frequency would you expect the wave to vibrate if an a mass, if an insect of mass this gram were trapped into the in addition to the spider. Okay, so yeah, so sorry, here we have a mistake, so it will be 0.2, 0.30. Okay, now what we are given is actually m is 0.3 plus 0.1, so it is actually 0.4 gram. Okay, or 0.4 times 10 to the power minus 3 kilogram. So if we have something like this, if the mass you increase to this, what will be the frequency? Okay, so for frequency we have to use this equation, 1 over 2 pi, okay, m over k over m. Okay, so 1 over 2 pi, and then k we just determined, k will not change because the k is constant for a spring. Okay, and m is now different. Okay, so if you plug all these values in your calculator, it should change the frequency from 15 hertz, what we had earlier, to 13 hertz. So the answer for the second question, so this is B, is 13 hertz. Okay, and this is actually K. Okay. All right. Next one. All right, so here we have a large motor in a factory causes a floor to vibrate up and down and frequency. So we are given the frequency 10 hertz. The amplitude of the floor motion near the motor is about 3 millimeter. Estimate the maximum acceleration. Okay, so we are given frequency 10 hertz and then amplitude is equal to 3 millimeter. Okay, millimeter to meter is this. Okay, we have to calculate a max. Okay, so a max is equal to omega square a, and omega, if you remember, is equal to 2 pi f, right? So we just replace omega by 2 pi f, and then we know f, that is 10, and we know a. Okay, so when you plug all these values in your calculator, it should give you the maximum acceleration, and that is equal to 11.8 meter per second square. Okay, all right. Next one. Okay. So we are given this equation, and from this equation you have to find amplitude, frequency, period, maximum speed, and the maximum acceleration. Okay. So to solve this problem, we basically need to know what is the general equation for x. So general equation for x is this, right? Cos omega t, or x equal to a cos 2 pi f t, right? This is the general equation. So if you compare this equation with this equation, you see that the coefficient of cos is a, and here the coefficient of cos is 0.30, and that means the amplitude is equal to 0.30 meter. Okay. Now frequency, if you want to calculate the frequency, so you need this 2 pi f to you have to equate 2 pi f to 8, right? So the coefficient of t is 2 pi f. So b, so 2 pi f equal to 8. Okay, so f equal to 8 over 2 pi, and that is equal to 1.27 hertz. Okay, so the frequency is 1.27 hertz. Okay. C, the time period. Time period is just the reciprocal of the frequency, so it will be 1.27, and that is equal to 0.79 second. Okay. And then D is the maximum speed. V max is omega A, right? Omega, if you see here, if you compare this equation and this equation, omega is basically equal to 8. So 8, and A is equal to 0.30, right? So this tells us that the Vmax is equal to 2.4 meter per second. And then E is maximum acceleration is equal to omega square A. So that is 8 square 0.30, and that is equal to 19.2 meter per second square. All right. Okay, now this problem is about the simple pendulum. Okay, for simple pendulum, if you remember from the last lecture, that we are basically interested on the frequency of the simple pendulum and the time period of the simple pendulum. And if you remember, the frequency was something like this: 1 over 2 pi, and then square root of G over L. Okay, so what we are given here is the L and the frequency. We have to determine the gravitational acceleration. So here, do not plug G equal to 9.8. So here we have to calculate and verify that it is equal to 9.8 or close to 9.8. So what we have to do, we have to basically square both sides and then solve it for G. So G is equal to 4 pi square F square L. So 4 pi square F is 0.8190 square, and then L is 37.10 given in centimeters, so we have to convert it into meter. Okay, and if you plug all these values in your calculator, it should give you 9.824 meter per second square. So here you see that it is very close to 9.80. So yeah, so this is the acceleration due to the gravity at the location where this experiment was done. All right. The next one. Actually, two more problems. Okay, so this one and another one. Okay. Now this is about the speed of the wave. Okay, wave speed. So what we are given? We are given the mass. We are given the length. We sorry. This is the length of the piano wire. Okay, so a wave whose wavelength, sorry. So this is the wavelength of the wave, and the length is this one, the mass is this one, and the tension is this one. What you have to calculate, you have to calculate the speed and frequency of the wave. Okay. All right. So first let's calculate the speed. Speed is either you can use f lambda if you know the frequency and lambda both, or you can use this equation, the tension and mu, right? So we cannot use the first equation because we know the lambda, but we do not know f. So we cannot use this equation. So we have to use this equation. Okay. So we are given Ft, the tension is 1000 Newton. So this is this one. Mu is not directly given, so we have to determine. So mu is mass per unit length, right? So mass is what? Mass is 15 kilogram and length is 300 meter. Okay. So that is equal to 0.05 kg per meter. So we have to plug this value here. Okay. So this tells us that the speed of the wave is 141 meter per second. Okay, so this much is the speed. Okay, so this is the first one. And then once we know the speed, we have to calculate the frequency. So to calculate frequency, we can use this equation because here we know the speed, we know the lambda, the wavelength, so we can determine the frequency by using this equation. So V is 141.4 and lambda is this one, the wavelength. Okay, and this tells us that the frequency of the wave is 471.4 hertz. All right. Okay. One more problem. Okay. Now we have another a piano wire. Okay, very similar to the wire we used in this problem. Okay. Okay, so the length is given, the mass is given for that piano wire. So we can use the similar strategy, similar thing that we use in the last problem to determine the tension. So here we have to calculate the tension, okay, given that we know the frequency. Okay. All right. So this is the frequency, this is the length, this is the mass. Okay. So we have to calculate the tension. Okay, so tension you can determine from this equation, so Ft over mu. Okay, so if you solve it for tension, you get Ft over mu. Okay, so this tells us that Ft is equal to mu v square. Okay, all right, so mu is mass per unit length. Okay, so that is mu, and V equal to F lambda, right? So V square equal to F square lambda square. Okay, so instead of V square, let me plug F square and lambda square. Okay. Now for fundamental frequency, so it says that the fundamental frequency is this one. So For fundamental frequency, if you remember that lambda 1 was equal to twice L, right? So the normally equation is lambda n equal to 2L over n, okay? So for fundamental frequency, for the first standing waves, okay, lambda 1 is equal to 2L because n equal to 1. So instead of lambda, we can, for fundamental frequency, we can substitute 2L. Okay, now we can plug all these values. Okay, m is what? M is 9 gram. So 9 times 10 to the power minus 3. L is what? L is 1.10. Basically, this L and this L is basically the same thing. Okay. F is what? F is 131 hertz. Okay, so this is meter, this is in kilogram, 2, and then L is 1.10 meter square. Okay, so when you plug all these values, you get the tension is equal to 680 Newton. Okay. Okay, so that's the first one. Number B says, what are the frequencies of the first 4 harmonics? Okay, so first harmonics, we already know that is 131 hertz, right? So that is already given. F2 will be 2F1. So 2F1 is 131. So it will be 262 hertz. F3, so the third harmonics will be this one. 3 times 131 equal to 393 hertz. And then the fourth harmonics is F4. 4F1 equal to 131, and that is equal to 524 hertz. Okay, and that's basically it for this chapter. Okay, so make sure you practice all these problem. Okay, all right, so basically that's it.